heat capacity. It is denoted by capital C and it is defined as the amount of heat required to raise the temperature of the substance by 1 degree. Okay, are you getting that? If we have to raise the temperature of any substance by 1 degree, then what amount of heat is required? That is the heat capacity. Okay, and mathematically this can be written as C is equals to Q upon delta T. Q is heat and delta T is time required. Okay, then moving on to the next slide, we have shown that heat capacity is a path function. How heat capacity is a path function? By using the expression that C is equals to Q over delta T, we can find out that it is a path function. Because Q is a path function, so it simply implies that heat capacity is also an path function. It is not depending upon state. So question can be asked that heat capacity is a path function or a state function. Okay, then moving on to the next slide, we have specific heat capacity. It is denoted by capital CS and it is the amount of heat required to raise the temperature of 1 gram of the substance by 1 degree. Okay, so you should remember the quantity of the substance, that is 1 gram. That's why we are using here the word specific. Okay, so this means 1 gram of the substance. So to raise the 1 gram of the substance, its temperature by 1 degree, then it becomes specific heat capacity and it is denoted by CS, that is equals to C over M. M is the mass of the substance in grams and it can be written as CS is equals to Q over M delta T. Okay, next one we have molar heat capacity. Molar heat capacity is the amount of heat required to raise the temperature of 1 mole of the substance by 1 degree. So here the molar word represents the 1 mole of the substance. Okay, when 1 mole of the substance is used, then the amount of heat required to raise the temperature by 1 degree is known as molar heat capacity. It is denoted by Cm, which is equals to C over N. C is heat capacity. So it becomes Q over N delta T. Okay, remember this point as well. Then moving on to the next slide, we have types of heat capacity. So there are 2 types of heat capacities. First one at constant volume and second one at constant pressure. At constant volume it is denoted by CV and which is equals to du over dt. Here the term Q is replaced by du because du is equals to QV, that is at constant volume heat absorbed is equals to change in internal energy, as I told you in my previous video. And second type, that is at constant pressure, that is Cp, this is equals to dH over dt. Q is replaced by dH because change in enthalpy is equals to heat absorbed at constant pressure. Okay, then moving on to the next slide, we have relationship, which is also very important. Relationship between Cp and Cv. Here we have the relationship between Cp and Cv. Cp minus Cv is equals to Nr for n moles, and also for 1 mole the relationship becomes Cp minus Cv is equals to R. So question can be asked directly from this expression. And one point that you should remember, that this expression is obeyed only for ideal gases. Okay. Now next one, we have heat capacity ratio. This is also important. What is heat capacity ratio? This is denoted by gamma. This is equals to Cp over Cv. This is known as heat capacity ratio. And this ratio gives atomicity. Remember this point. This ratio gives atomicity. How this gives atomicity? You can see in the table that for monoatomic gas, the ratio becomes 1.66. For diatomic like H2O2, it becomes 1.40. For triatomic gas like O3, it becomes 1.30. Okay, so you should remember these values. Next one, we have instruments. Sometimes instruments are asked that what type of instruments are used to measure the energy changes in chemical and physical reactions. So calorimetry is used to measure the energy changes. Remember this point. For example, to measure delta U, that is change in internal energy, bomb calorimeter is used. And to measure delta H, that is change in enthalpy, the coffee cup calorimeter is used. And also one important point, that bomb calorimeter is used to determine the calorific value of food and fuel. This question can be asked. Next one, we have problems for you, and you should answer these problems in your comment. First problem is related to the state and path functions, and second problem is related to the determination or measurement. Okay, I told you during the video that what are state and path functions, and also the measuring methods, or what instruments are used to measure the calorific values. So comment your answer, and thanks for watching the video.